Good morning, students. Today we are going to solve few problems of electrostatics from JEE Main 2023. Question number 1. A 10 microcoulomb charge is divided into two parts and placed at 1 centimeter distance so that the repulsive force between the two charges is maximum. The charges of the 2 points are there are four options.
Let us consider the charge is Q and this charge is divided into two parts. First one is Q1 and second one is Q2. Q1 is equal to X and Q2 is equal to Q minus X. Therefore, from simple Coulomb's law, the repulsive force between these two charges is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Suppose this part is constant K and Q1 is X and Q2 is Q minus X by R square. Now, according to the given question, the force will be maximum for this charge is X and this charge is Q minus X. Now, the maximum force can happen only if df dx is equal to 0. So if we differentiate this part, this will be k by r square, which is constant. For this x, only q minus x plus for this part x into this is minus 1 is equal to 0. Therefore, q minus 2x is equal to 0 or q is equal to 2x. Therefore, x is equal to q by 2. Therefore, we can write for this problem, since q is equal to 10 microcoulomb, it is given. Since q is equal to 10 microcoulomb, which is given, now the first charge will be, that is q1 is equal to x is equal to q by 2 is equal to 5 microcoulomb and q2 is equal to q minus x is equal to 10 minus 5 is equal to 5 microcoulomb. Therefore, the answer C is the correct option. This is the correct option.
Second problem. If two charges Q1 and Q2 are separated with a distance d and placed in a medium of dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? There are four options.
According to the given question, the two charges, say Q1 and Q2, are separated a distance d in a medium are separated by a distance d in a medium where the dielectric constant of the medium is K. Therefore, in that medium, the force between the two charges is F is equal to 1 by 4 pi epsilon 0 into K Q1 Q2 by d square. And if we keep the same charge in air, consider the distance between these two charges for the same force will be R. So for this case, the force F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Since these two forces are same, therefore we can write 1 by 4 pi epsilon 0 K into Q1 Q2 by d square is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Therefore, here 4 pi epsilon 0 can be cancelled out both side. Q1 Q2 can be cancelled out both side. Only K into d square is equal to R square, or R square is equal to K into d square. Therefore, R is equal to root over K into d. So, the correct option is answer A.
Question number 3. A point charge of 10 microcoulomb is placed at the origin. At what location on the x-axis should a point charge of 40 microcoulomb be placed so that the net electric field is 0 at x is equal to 2 centimeter on the x-axis?
Let us consider the Cartesian coordinate system, and according to the given question, the charge 10 microcoulomb is located at the origin of the Cartesian coordinate system. Another charge, suppose q prime, which is 40 microcoulomb, is located at a distance, suppose x centimeter from the origin, so that at a distance 2 centimeter from the origin the electric field is 0. So the electric field due to the charge 10 microcoulomb is 1 by 4 pi epsilon 0 q into 2 into 10 to the minus 2 whole square. This term is because the distance here is in CGS units, but we are calculating the entire equation in SI units. Again, another part, the electric field due to the charge q prime at point P is 1 by 4 pi epsilon 0 q prime by x minus 2. The distance is x, and here the distance is 2 centimeter. So the distance of the point P from q prime is x minus 2 centimeter. So we are given here x minus 2 into 10 to the minus 2 whole square. Now, according to the given question, the electric field at point P is 0. So E is equal to E prime at point P. Therefore, 1 by 4 pi epsilon 0 q by 2 into 10 to the power minus 2 whole square is equal to 1 by 4 pi epsilon 0 q prime by x minus 2 whole square into 10 to the power minus 2 whole square. Therefore, q by 2 square into 10 to the power minus 2 square is equal to q prime by x minus 2 square into 10 to the power minus 2 square. These two will be cancelled out, and for this case q into x minus 2 whole square is equal to q prime into 2 whole square. Here q is 10 microcoulomb into x minus 2 whole square, and q prime is 40 microcoulomb, and 2 square is 4. Therefore, x minus 2 whole square is equal to 40 into 4 by 10 means 16, or x minus 2 is equal to 4. Therefore, x is equal to 4 plus 2 is equal to 6 centimeter. So the answer D is the correct option. Now let us take a conceptual question. In a cuboid of dimension 12 by 12 by L, a charge Q is placed at the center of the surface S having area 4L square. The flux through the opposite surface to S is given by the four options here. Now look at the figure. This is the cuboid. The surface here have the sides 12 by 12, and this side is L. Suppose the charge according to the question is situated on the surface here. This is say S. The surface area of this surface S is 12 by 12 into 12, that is 4L square. According to the given question, the flux through the opposite surface this is any one of the four options. Now to solve this problem, let us draw a cube of sides 12, or we can complete the cuboid to a cube with sides 12, and suppose this charge is situated at the middle of the cube on this surface, and for this case the flux of this charge Q through the all surfaces are equal according to Gauss's theorem. So we can write the total flux phi is equal to q by epsilon 0. This is actually the flux through the total surface. Therefore, through any one of the surface, like this 12 by 12 surface, or this 12 by 12 surface, or any one of the 12 by 12 surface, is any 12 by 12 surface is equal to 1 by 6 into q by epsilon 0. Since there are 6 surfaces and the flux through any one of the surface is equal to the other one of the other surface, so we can divide this q by epsilon 0 by 6. So the flux through any one surface of 2 by or 2 by 12 by 12 surface is 1 by 6 q by epsilon 0. That is, option C is the correct option.
Question number 5. A dipole comprises of two charged particles of identical magnitude q and opposite in nature. The mass m of the positive charged particle is half of the mass of the negative charged particle. The two charges are separated by a distance L. If the dipole is placed in an uniform electric field E in such a way that dipole axis makes a very small angle with the electric field E, the angular frequency of oscillation of the dipole when released is given by, there are four options.
Since the masses of both ends of the dipole are not equal, so we need to find out the center of mass of the dipole. About which it can be oscillated. Now, suppose the dipole, according to the given question, is this. The mass of the first charge is, say, m, and the second charge is 2m. So the center of mass of the dipole will be, suppose, on any point on along the line joining the two masses. Let us find out the center of mass of the dipole. The length of the dipole is L. So the center of mass x is equal to, according to the equation of center of mass, m1 x1 plus m2 x2 by m1 plus m2, where m1 is the first mass, m2 is the second mass, x1 is the coordinate of the first mass, and m2 is x2 is the coordinate of the second mass. Here the coordinate of m1 suppose is 0. If we consider it at the origin, if we consider the first mass at the origin, then its coordinate will be 0. So for the first mass, m into 0 plus, for m2 it is actually 2m into L by m plus 2m is equal to 2ml by 3m is equal to 2 by 3 L. So the position of the center of mass from the mass m is two by 3 L, and from the mass 2m is L by 3. Now let us calculate the moment of inertia of the dipole. I is equal to 2m into L by 3 whole square plus m into 2L by 3 whole square is equal to 2mL square by 9 plus 4mL square by 9 is equal to 6mL square by 9 is equal to 2mL square by 3. This is the moment of inertia of the dipole. Now, if we place the dipole in the electric field, E, and the dipole makes an angle theta with the electric field, which is very small, then the torque on the dipole will be tau is equal to P cross E, where P is the dipole moment of the dipole and E is the electric field. The mass of the positive charge is m, the mass of the negative charge is 2m. So the torque will be Q into L into E sine theta. In another notation, torque can be written as I into alpha. In another notation, torque can be written as I into alpha, where I is the moment of inertia, alpha is the angular acceleration. Let us consider the first one is equation number 1 and the second one is equation number 2. Since these two equations are similar, so we can write tau is equal to I alpha is equal to Q into L into E sine theta. Therefore, alpha is equal to Q into L into E sine theta by I. Since theta is very small, so we can write sine theta is about theta. Therefore, alpha is equal to Q into L into E by I into theta. Again, for small oscillation, we know the relation between alpha and theta is alpha is equal to omega square into theta, where omega is the angular velocity. Angular frequency or angular velocity. So, for this case, we can write omega square is equal to Q L into E by I. Therefore, this will be Q L E by I. I is equal to, we already derived, 2m L square by 3. This is actually capital L. This is capital L by 2m L square by 3. This is 3ql E by 2m L square is equal to 3q E by 2m L. Finally, omega is equal to root over 3qE by 2m L. So, no option is matched with the answer.